All right, in our first example, we're gonna set up our base for the entire lesson. So let's make sure we really understand what we're talking about in this first example. The question is, when you draw an altitude to the hypotenuse of a right triangle, you create three triangles. How are the triangles related? So here we can see we have triangle ABC. This is a right triangle, so let's go ahead and draw in our right angle. It is going to be over here at angle C. Well, that was kind of sloppy. All right, so angle C is our right triangle. So the thing that we want to know or keep in mind with right triangles is you have a right angle, the hypotenuse, but then I'm going to reference the two legs that form the right angle. One of them is always going to be a short leg, so AC is the short leg, and one of them is going to be the long leg. In this case, CB is the long leg. AB, I'm never going to call that a leg because that is the hypotenuse of the right triangle. A right triangle has a hypotenuse and two legs, a short leg and a long leg. So to start, I want us to redraw this triangle, and we're going to do a lot of this in this lesson. We're going to redraw our triangle where I can clearly see I have a long leg, I have a short leg, and I have the right angle. I'm actually going to go ahead and label that. We're going to put the long leg as our vertical leg, and then the short leg will be the horizontal one. So if this is triangle ABC, I can see that C is the right angle. So I'm going to label a C right here. And then the short leg is down here. So if I come up here and I see the short leg is over here from C to A, that tells me that that vertex is A, and then the long leg is from C to B, so I'm going to put a B up here, and there is our same triangle, just transformed a little bit. Actually, it's just a rotation. We just rotated it, so we can look at it as a pretty clear right triangle. Okay, so that is the whole triangle. So what we're going to do is we're going to draw in an altitude to the hypotenuse of the right triangle. So what an altitude is going to do, the way that this triangle is drawn is actually helpful because our hypotenuse is horizontal. What an altitude does is it goes from a vertex and it hits the opposite side and forms a right angle. So it's actually going to come from our right angle, it's going to hit this hypotenuse. So let's draw in. This is the altitude and it forms a right angle. Let's go ahead and label that D. So we have the big triangle, the whole thing, ABC, and when we draw in that altitude from the right angle of the big triangle, it gives us two more right triangles. We have ADC and we have BDC. So what we're going to do is we're going to draw out those two triangles over here, right next to these. But we're going to structure it the same way. We're going to have the long leg, the short leg, and the hypotenuse. And there's our right triangle. So let's start by drawing this triangle over here. To label our three vertices, we can see that the right angle is at D. So I'm going to go ahead and label D. The short side, so here's our triangle, here's our right triangle. Opposite of the right angle is the hypotenuse. This is the short leg of our triangle here on the left from D to A. So we put the short leg on the bottom here, so I know that that's going to be an A. And then the long leg is of just this triangle over here is from D to C. So I know that we have C up there. So basically, this triangle, when I redraw it this way, so I'm kind of trying to match these up a little bit. Things are not drawn to scale, by the way, so let's just keep that in mind. This is just a reflection. This triangle just got reflected, but there it is there. Now, let's take our third triangle over here, and let's redraw it. So again, I'm going to have the long leg vertical, the short leg here on the bottom. Our right angle goes right here. So we are drawing this triangle right here. We can see that the right angle is at D, because remember, if there's a right angle on the left, there's one on the right. So we're going to draw, actually maybe I should color code these. Here is that green triangle we just drew, and now here's the blue one. And then, oh, I just made this a little bit messier, but do you guys see the three triangles we're working with? So now we're looking at this blue triangle. I'm just redrawing it over there. We just identified that the right angle is D. Now as we look at this, let's identify the short leg. So the short leg is from D to C. So over here, D to C, short leg. Long leg is from D to B. So I know that this is a B up there. All right, so some things that we want to add into our pictures. We can see that angle A is part of the big triangle, and it's part of our green triangle. Angle B over here is part of our big triangle, and it's also part of our blue triangle, one of those. Okay. So those are the three triangles, and we just redrew them so they're really easy to compare. That's what we're going to do with most triangles in this lesson. Some things that we can take note of is that triangle ABC is similar to triangle ACD. So these are the first two triangles. ABC is similar to ACD. And see how nicely those are all lined up where they should be. A up here to B, down to C. A up here to C, down to D. The reason why these two triangles are similar is they both have a right angle and they both have angle A. So they're similar by the angle similarity. All right, well, angle ABC is also similar to triangle CBD. Again, A up to B, down to C, C up to B, down to D. It's really easy to get these in the correct order when we draw our triangles the same. Again, both of those have the right triangle, and they both have angle B. So they have two congruent angles. So those are similar by our angle similarity. So therefore, what that means is that triangle ABC is similar to triangle ACD, which is also similar to triangle CBD. So essentially, because this big triangle is similar to both of the smaller ones, that makes the two smaller ones similar to each other as well. So when you have a right triangle, you draw in an altitude from the right angle, you have three right triangles, they are all similar, which means they will have congruent angles and proportional sides. Okay, so here's what that theorem is. The altitude to the hypotenuse of a right triangle. So here's the altitude, it's to the hypotenuse, it's hitting the hypotenuse of the right triangle right here, divides the triangle into two triangles that are similar to the original triangle and to each other. So I was maybe going to redraw these, but we just went through all that detail up here, so I don't think we need to redo it. So just make sure that that's nice and neat. Again, what you want to remember is when we redraw triangles, we're going to rotate, reflect, whatever we can so that we have the long leg on the vertical side, the short leg horizontal, and then that hypotenuse connecting them, and always with the right angle right there. And when we do that, we have them set up as all the corresponding parts are similar. So like AC is proportional to AD, which is also proportional to CD, and we can work with that.